So in the last class, what we did was we basically understood TensorFlow object detection but on MS Coco dataset. So here what we did was we did not do any training. We already had the model, we had the pre-trained weights and everything. We just downloaded those so that it could work for our dataset, right? That was what we did here. Now what we will do is basically once we have done the MS Coco dataset, we will understand how we can use TensorFlow object detection for our dataset, that is for a custom dataset. So before we start that, let me show you what our custom dataset actually looks like, alright? So these are some of the images, alright? So we have basically cards and our task is basically for a model to understand the cards here. Okay, so this is basically what I would call as our next or our third project. So you can see you have these cards and your task is basically for your model to see this and identify, okay, this is a 10 number card, or this is a jack, or this is a queen or king. Okay, so that is basically our task here. This is basically our data set. You will be provided with a data set, don't have to worry. But for now, our basic task is we have these data sets, these cards, and we have to basically do an object detection on them. So here's the thing. If you have to do object detection, the very first thing that you need is a data set. So you will be provided with a data set. What your data set should contain is, it should contain, this is your data set in images, and it should contain train folder and test folder. In train folder you will have 80% of the data, test will have 20% data. So this is basically your whole task. You have the data set, you have train and test, and you have 80% of the data in train and 20% in test. So this is now how your data set will look like. Once you have gathered all these images, the next thing that we have to do is basically label these images. So for that, what we will do is, we have opened our terminal. So we have the same TFOD, alright. So what I have done is basically I have created a Conda environment, and once you have created the Conda environment, I have used Python 3.6. If you see here, you have the steps. This is the same thing, right? So here this is Conda create -n, your environment name, and Python equal to 3.6 I am using. Okay. So this is the same thing here. You are not changing anything. Once you create your environment, you can activate your environment in this format. Alright, so you remember in the last class, I have already created the environment. So for now, what I will be doing is, I will be activating it. So let me activate. Now inside this, what I will be doing is, I will be installing label img. So this takes some time. Obviously every installation takes time. Okay. Let us go into label img, alright. Let us go and look into that. So this is your label img. So this is okay, capital I. So this is basically how you will be installing your label img using pip. So it is very easy to install. So now the installation has basically started. So you are downloading label img. So what label img basically does is, it helps you in going through everything and basically opening and labeling your images. See, before you have, even if you have the images, you have to label those images. If you remember, in the last time I showed you label map.pbtxt, right? And in label map.pbtxt, what you had the ID of the object and what the object represents. So ID1, the object was person. So in that way, you need to label. But it was not that. In MS Coco dataset, they also have what is known as, you had the images, but at the same time you also had the x y coordinates and width and height coordinates. You required this because if you remember, we were doing all this regression, right? And in these regressions, these were very much required. So you need to have these images, as well as for every image you need to have these coordinates. Okay, so this basically you have to label on your own. We'll see how. Okay, we'll see. So the whole thing has been completed. So you have installed label img. All right, so what you will do next is, you will open label img. So this is your label img2. Let us go for OpenDIR. I'll show you how this is working. So let us go into our images. So inside images we had test and train. Let us go into train and open this, because we are using an open directory, so you have to select a directory to open. So if you select the directory, so now here you can see the dataset that you are provided with has already been labeled. All right, but in your case what you have to do is, basically you will have to label each and everything. How will you do that? So you have to start with create rectangle box, and then you have to start, and then you have to label the whole thing. All right, so right now I am not doing anything because the whole thing has already been done, so I'll cancel it. But yeah, in this manner you can select here, you can select rectangular box, and you have to label the whole thing. And you need to remember one thing, you have Pascal VOC here. If you change this, this becomes YOLO. So you need to keep this as Pascal VOC. Pascal VOC is the format that is used for our data set. All right, so for TFOD you require Pascal VOC. When we will be doing YOLO, we will have to change the format to YOLO, but for now it is Pascal VOC. Once you have this, now you can go to the next image. So this is your next image. So I did no, because I did not want to make any changes there, the ones that I did already. So we are going to just keep it like this. So you can see here, this is your next image, then this is your next image, and so on. You can see, so these are basically all the images that you have. So it is going from here, all the images. So what happens is, in open directory, it opens a directory. Once the directory is opened, it will go through all those images. All right, by the way, the only image formats that TFOD uses is JPG, JPEG and PNG. That is it, and nothing else. No other format will be used. Alright, so whenever you have the images, make sure that they are of this particular format. So once you have done the labelings, you can close this. So what will happen is, if you will go here and you will go to the images, so you will see for every image it has created an XML file. These XML files are what will be, see, inside these XML files you will have what? You will have the X, Y, W and H coordinate for all the objects. If you remember, in each image you had what? 4 cards, sometimes 4, sometimes 3, but you had more than one card. So for each card it will, for each card will be treated as one object. So for each object it will give you this X, Y, W and H, and this will be for all the images. So if you look into one of these XML files, right, see, you have these XML files. Wait, let me open this using my editor. So you can see here, right, so you have the annotation. What is the folder it is in? It is in train folder. The file name, this is camera image 1, okay, and then you have the path, in which path it is in. All right, once you have that, now you have the width, height and depth of the image. All right, this is for the image. You have nothing here. This is everything. These are for the image. This will be the same for most images. Okay, so this only the name, file name will change, but the width, height and all is same. Then you have the object. Now this is the object part. In object you have queen. Okay, there is no pose and nothing else here, but yeah, in queen you have X minimum, X Y minimum, X maximum, Y maximum. So what that means is, X minimum and Y minimum, if you see, if you think of the coordinates and everything, so this will be your X minimum, Y minimum. If you think about it, this is the one that is the minimum and this part will be the maximum. x max, y max. Alright, so it will give you this and this coordinate, and using these two coordinates you will draw your bounding box. So this is basically the whole thing. So for every object it will be giving that. So this is for queen. This is one. Then there is also another object in this image. If you look at this image, you have what? 2 queens and 1 10. So you have 3 objects here. This is the first queen. This is your other queen. Again it has x min, y min, x max and y max, and finally you have 10. In 10 also you have these. So this is basically how your XML files will be there. These files are created using your label img. Once you have drawn the boxes, right, you click on save. Once save happens, for each JPEG or for each image it creates an XML. Alright, so this is what is happening basically. For each image now you are having an XML file. So in this way you have an XML file for each image. So if you have, let's say, 200 images, so you will also have 200 XML files. Alright, now these are the steps that you have to make sure that you are doing, because this is your custom data set. So you have to first create the data set. So our very first task was create data set. So our data set has been created. If you look here, so this is all for your training. Now you also have a test. So now this is all for test. All these images are test images, and for each of this image also it has been labeled, hence you have this XML file, right? Okay, so you have training and testing. One thing you need to make sure is the number of training images should be number of XML images in training also. Okay, so the number of images should be equal to the number of XML files. Once you have that, you can go on to the next part. Okay, so your folder is basically, right, you have the image folder. Inside this image folder you have two other things. One is train folder. Inside you have training images with their XML files, and then you have a test folder. Inside this test folder you have your test images and those XML files. Alright, so now your dataset has been created. So this dataset is inside this utils folder. You will be provided with this utils folder, don't worry. But the only thing is, if you are doing on some different dataset, you have to make the changes here. Okay, so these images, train and test, you need to make changes. You have that. Now the images are there. The next thing we will be doing is we will be downloading the models here. So you can download the models from here. So you have the repo, you can download the repo from here. The whole thing you can download, then you can extract it. So I have extracted this is here. Alright, this label img master is basically, I downloaded this using here. So I downloaded it without using pip. So I downloaded using all these files and then cloning the repo and everything. Yeah, that is a big process. Now I see that there are also easier processes like pip. It was not there earlier, but now they have those. So that is a good thing. So you can directly download using pip. Alright. So you have the label img. So now what you know is basically how your whole data set works, how your data set looks like, how you need to make sure of your data set. So one thing you have to remember is this creating data set is a very hectic process. Alright, and for any training, any type of training, for any, like let's say you have 3 objects for training. So in that case, for each object you should have at least minimum of 500 images. So it is not that easy, I know, labeling 5000 images, because see, for each dataset you need to have at least 5000 different images so that model finally understands what is happening. Alright, so you need these many images, and for each object you need at least 500 images. It can be more than that obviously, but on a total the number of training images should be 5000 at least. So it is very difficult to label these, but yeah, it is time consuming, I know, and it should be labeled properly hence. So you, even then it is very difficult, but I would suggest to make sure that you are labeling it properly. So that is the difficult part. Once that is done, now that we have to do is a very simple parts. These things we were already doing when we were doing the TensorFlow object detection, when we were using it on MS Coco. Alright, so you have the models. Inside the models you have all these files. We are interested in the research folder. Again I am telling you, the research folder, the research, this is basically your directory or your parent directory, right? So all your task, everything will be done using this folder itself, research folder. So you need to make sure you are always inside the research folder, and whatever changes you are making are inside the research folder, parent folder. This is your parent folder. So once you have that, the next thing that we have to do is, you have this, okay, I'll be providing this obviously. You have to see, we downloaded the model, we downloaded the see, I have 4 things already downloaded here with me. So I have the model downloaded, and we downloaded this label img. Once these two are done, I will download the training that I want to do, the architecture of the model using the TensorFlow Zoo. You remember this, we did this in the last class also. So this is your TensorFlow Zoo, and from here you have to download. I am using SSD MobileNet V1 Coco, just like the last day, okay. I have not made any changes there. And then you have this utils. Inside this utils you have a lot of things. We talked about what was inside images, we'll talk about the rest later on, okay. So you have this whole thing. So go inside models, inside research, and this is your whole thing. You have your SSD V1 Coco here itself. And so what we are going to do is, we are going to follow each and every step like we did in the last time, okay. Some of the steps are going to be the same. So you created your environment, you activated your environment. Then you are going to download this whole pip install, Pillow, LXML, Python and everything. Okay, so let us download this. So we already downloaded, because since this is the same activation, same environment, what is going to happen is everything is going to be the same thing like it was yesterday. Alright. So you can see we are downloading Pillow, LXML, Python, Jupyter, Matplotlib and everything. Okay, so most of the things you know what they do. Python is basically to help convert C and Python with each other, because it is important. OpenCV you know, TensorFlow you know, Pandas, Matplotlib, Jupyter, all these you know. ContextLib is also one of the things used, and LXML as well as Pillow. We'll talk about this, okay, we'll talk about this. So we have the whole thing now, okay. So all the setup has been done. Then we will download protobuf. Again, this was already done in the last class. So all the setup is already done for my system. You have to make sure that it is done in your system also. What you can do is, basically instead of using the same that we did last time in MS Coco dataset, you can create a new environment and do everything from the scratch. It is good to do everything from the scratch because it helps you remembering more. Okay, so I have downloaded protobuf also. So the next thing I'll be doing is, I'll be converting these proto files, okay, but I'll have to go inside the research folder first. Now I am inside the research folder. Here what I will be doing is, basically I'll be converting the protobuf. So we already downloaded the statement. If you remember, I talked about the statement last time. So what was this statement doing basically? So protobuf statement is used. This is used so that you can convert your proto files into Python files. But if you remember, we have already converted it in the last class. If you can see here, I think it is already converted. But let us do it again, that is not a problem. So you can see all of these are already converted. Let us do it again. So nothing happened because it was already done. You can see here it was already done, so nothing happened. So once you have converted your proto files into Python files, the next thing you will be doing is, basically now are the steps that are required, that are different from that was in the last part, okay. So here you will be going inside utils, copy everything inside, okay. So everything has been copied. Go inside models, in research, paste everything here. Okay, you have pasted everything here. So now what you will be doing is, basically, see, to do this, to do the training, you need a few things. You need a label map.pbtxt. For your, this is for custom training, alright. So for custom training you need this. Then you also need a record file. Then you need a config file. We'll talk about one of these slowly everything, okay. So first let us talk about the very first thing that we will be doing. You will be converting this into a .record file. So we have the labels, right? You have the labels. In these labels, what do you have? You have these XML files, and these XML files, what do they contain? They contain the object name and in this object name has x, y coordinates, okay, x minimum, y minimum, x maximum, y maximum. So you have these. What you are going to do is you are going to convert these into record files. So you cannot convert them directly into records, okay. So what you have to do is first convert these XML to CSV files. Once you convert these to CSV files, then you can convert this into record files. So our very first step is to convert these into CSV files. If you go here and see inside utils, you already have XML to CSV. If you see inside this, what is happening is here for folder in train and test, alright, and these folders are inside what? Inside images. So we are going to go inside the images folder. If you remember here, images folder, train and test, okay. Then what we will be doing for each of this image, then we will be converting the XML to CSV. So here what is happening is you are converting the XML to CSV, right, and you have this whole thing. So this is basically what will be used. Now we are in the research path, so we will be doing that, okay. So what you can do is go here and copy. So your XML has been converted to CSV. Like you can see, it is done 2 times because it will be done for the training and for the testing. So if you will go here and see now, so after converting, where will this be stored? So it will be stored inside images, I suppose. So images, yeah. So you see, you have train labels.csv, test labels.csv. Let us look into this, alright. So you can see here, you have the file name, you have the width, height, class, x minimum, y minimum, x maximum, y maximum, alright, and they are differentiated or separated using commas. So you have the file name, which image this is, you have the height and width of the image, you have what? The class of the image, which class it belongs to, whether it is a jack, queen, 10, ace, 9, okay, and then you have the x minimum, y minimum, x maximum, y maximum. So you have this. So you have for test, in the same way you will also have for C, file name, width, height, class, x minimum, y minimum, x maximum, y maximum. If you see here, XML to CSV file, here you have all the column names, file name, width, height, class, x minimum, y minimum, x maximum, y maximum, right? So you have this. So here what they will be doing is for every XML file they will be going through and they will be identifying all the objects and they will be storing them with the file name, width, height and so on, right? You got the idea, I am pretty sure. So you can see here, once you have converted this, it has given you where you can save the whole folder. So this is being stored in the images folder with labels.csv name. Okay, so you will have train labels.csv and test labels.csv, alright. So these has been stored. Now you have converted them into CSV files. Your main target is, your main target is not to convert to CSV. No, you have to convert this into record files, right? So our first step is done. XML to CSV is done. Now we will have to convert this CSV into record files. By the way, I think did we do a setup? Okay, I think it is not mentioned here, but if you remember, we did it last time, right? So we have to do it again. So there is this called, it will not work without this, alright. So you also have to do this python setup.py install. So this is usually done before the protobuf, but it's alright, you can do it afterwards also. So before running or training, you have to just complete this, alright. So this is done. Now once you have done this here, so this step has been completed. XML to CSV is completed. Now what we will be doing is we will be generating TF record. So the record that we are generating, that we are going to do using this command. So copy this command. So we are running generate tfrecord.py CSV input. So this shows you the input. The input is in CSV format and this CSV file is in images/train labels.csv. Okay, and images dir is where your images are. So your images are inside images/train and your final output path will be train.record. So this will be inside the research folder, alright. So you are understanding it, it is not that difficult. You have generate TF record, the file that I'll be running, and it asks for the input, the CSV input. This is your path to CSV input, this is your path to images, and this is your final output. So you will have this train.record. Now you cannot see, if you open train.record you will not be able to open, okay. So you have something train.record here, see. So these are 0 and 1 files, you cannot open these. See, you cannot open these. You cannot open these. So again, let us skip this. So you have converted this into record file. Now this is for training part. Let us do the same for testing part. So let us copy this again. The same thing here, generate TF record. You have your CSV input. So this input is inside test label CSV, which is inside the images folder. If you will look here, let us go back again. So you have images folder, see test labels.csv. So this is your CSV input directory. Then you have images directory. Images directory is in images/test. So inside here you have all your test images, okay. Then what you are having is basically output path. Your output path is test.record. So you also have a test.record here. See, you have test.record and train.record. Now you have this record file. So this step is over. So we have completed the second step here, right? Cool. There is one thing, okay. So when you are making the changes for your custom data, let us look into what we have inside generate TF record. Because we are using this file and running this file, we know what is inside XML to CSV because we ran that Python file and we saw what was inside this Python file. Now let us look into what is inside generate TF record file. So you have this generate TF record file. So there are a lot of things. Most of these have been written in TensorFlow 1. So these are basically your argument inputs that we will be taking. So you have CSV input, image dir, output path, okay. So these are all right. Then here what happens is basically you are converting this into TF records, okay. So this is basically a whole thing to convert into TF records. You can find this in the documentation, how to convert to TF records. So this is nothing, this is not that big a deal, and you already have this inside here, so that is not the thing. The only thing, when you will be doing your data set, which is not the data set of the cards, in that case what you will be doing is basically you will be making a changes here. Alright, these are the places where you have to make the changes. So here you have to give your numbers IDs, okay, object IDs. So if there is a number 9 or the card is a number 9 card, then you will return 1. If there is a card with number 10, it will return 2. If this is a card with jack, it will return 3. In that way, you have to make the changes here depending upon what your objects are, okay. So since our objects are basically card numbers, so we have 9, 10, jack, queen, king, ace, okay. These 6 objects we will be training on, and we have return 1, 2, 3, 4, 5 and 6, alright. This whole thing is there. This is the place where you have to make the whole change, alright. So when we were talking about this XML to CSV, you don't have to make changes here if you make sure your directory is, or your all the files are in the same directory. This is where you have to make changes, okay. Here the only change that you have to make is basically in this, here this function. So class text to input int, this function you have to make the changes depending upon whatever classes you have. Okay, so we looked into a generate TF record, we looked into XML to CSV. Now, once that is done, what we will do is basically, we'll go here. The next thing is basically to make changes into your config file. But before that, what we will be doing is, we will be looking into label map. So, where exactly is your label map? If you go here, inside utils, and inside training you have the label map.pbtxt. If you remember in the last one when we were doing MS Coco, our label map was, what was our label map? We had, see, we had object 1, person, and you need this label map because it tells you which number is what thing, okay. So you need this. So this was how the whole thing was, and you had till object 90. This goes on till object 90. So for your custom data set, because here it goes to 90 because you have the MS Coco data set. but we are doing on custom data set, so our label map is going to be different. Let us look into our label map. So this is your label map. Here what you are doing is you have written in the format how it was written in the MS Coco label map. So you have item, you have ID, you have name. If you see here in generate TF record also, for 9 you had input label 1. So here also for ID 1 you have name 9, for ID 2 you have 10. See here also for 10 you have label 2. The same way 3 for jack, 4 for queen, 5 for king, 6 for ace. So 3 jack, 4 queen, 5 king, 6 ace. Alright. So this format you have to make sure that the numbers match here and there, otherwise this is not going to work. So in this way you will create your label label map.pbtxt. By the way, the format has to be .pbtxt, alright. It does not mean you can write .txt or anything else. It has to be .pbtxt. So what changes have we done till yet? So the first change we did was basically in generate TF record. So in generate TF record you have to change your class according to whatever labels you have. Next we have to make changes in label map.pbtxt. So now let us look here. So we now have both our label map.pbtxt and our record file. These two are done. So now let us come to the config file. So we will now be making changes in the config file. So where can you get the config file first of all? So you can get the config file here. So models, research, object detection, inside samples you have configs. Inside configs you have all these config files. We will be using SSD MobileNet, alright, SSD MobileNet v1 Coco. So let us look into this. Where is SSD MobileNet v1 Coco? So this is your SSD MobileNet v1 Coco. So what we are going to do is we are going to copy this and we are going to paste this inside our training. So training folder was there in the utils folder. In this folder only you had that label pbtxt file. Okay, so inside training you will paste this here, right? And see, this was the next step. You have to change this from research object detection samples config to research training. So now this is inside our training along with label map.pbtxt. Here this is not done. We have to make a few changes here. Let us go inside and let us see what changes we have to make. Alright. So you have to make a few changes. So where again are we making the changes? Okay, let us make this whole column, whole page where we talk about changes for custom. So changes for custom training. So the very first change we are doing is in label map.pbtxt. The second change that we will be doing in is your generate TF record. Generate TF record. Now my third change will be in this file, that is your .config file. Now let us look into a config file and what changes we have to do. First of all, the very first change here we will be doing is number of classes. So 90 classes is because we are doing the MS Coco dataset. We are not doing the MS Coco dataset, so we have to make the change here. So we are having how many classes? 6 classes. What are those classes? 9, 10, king, queen, jack, ace. Alright, so that is by 6 classes. First change. So inside this also, let us make this. Let us write first change, number of classes. Second change, after number of classes your second change will be, see if you read here, this is right, did SSD MobileNet v1 configuration for MS Coco dataset, alright, and you have to change the path wherever it is written path to be configured. So these areas you have to make changes. So let us go there. See here, this is your first path to be configured. So this is, it's written model.ckpt. So model.ckpt. The next is, what is this path? Fine tune checkpoint. So next you have to change in fine tune checkpoint. So here you have to give your path to model.ckpt. So model.ckpt is basically, if you go here, you have the SSD. Inside this SSD, just a minute, not this one. This was the SSD that we downloaded when we were running the object detection tutorial notebook. Alright, this is that I have downloaded from here, from the zoo. Once you have downloaded it, right, wait, yeah, this is the zoo and this is what I have downloaded from the zoo. Okay, so what I'm going to do is I'm going to copy this into research and not use that one, because that one was used for MS Coco. So here there are going to be some changes you will see. So in there you just had frozen inference graph, right? Here you have model.ckpt. So if you remember what I told you in the last time, it was that these three model.ckpts, these three add up to the actual model. So where is this model inside? It is inside this folder. So if you go here, let us rename this, alright. Let us not keep it this one. Let us keep it just SSD MobileNet, alright. So let us just keep this for easier understanding. So this is SSD MobileNet. So inside this you have the model.ckpt. So here you change the path. You have SSD MobileNet. Alright. The next thing you will be changing is the number of steps. So here it has 2 lakh steps. But for now we are not going to do 2 lakhs. The reason why is because it takes a lot of time. We are going to keep it small. So let us keep 20 steps for now. We will be doing more when you will be doing, right? When you will be training, you have to train this for at least 5,000 to 10,000 steps. It is not going to work before that. You are not going to get anything. But because it takes a lot of time, so for showing, I'll just be doing for 20 steps. Then you made this change here. The next change that you will be making is basically here. Train input reader, TF record input reader, input path. So you will be making changes in train input reader, TF record input reader, and inside that you have what? Input path. So this is your third change. So here what you will be doing is basically you will be giving your path to train record. Since we are in the research folder, so this is basically train.record, nothing else. So here it is written MS Coco, but we do not need that because we have train.record here. So you have train.record. So the train.record is in the research folder, I suppose. Yes. So we do not have to give any other path. Right? This is the path. Next path is label map path. So inside this you also have your label map path. So this also needs to be changed. So this is your fourth change basically. So where is your label map? Label map is inside training. Right? Inside training you have label map.pbtxt. So let us make the change here. So training / label map pbtxt, right? You did this change. Next you will be doing the same changes for eval input reader now. Okay, so here also you have the input path and label map path. Eval input reader is basically for evaluation your input reader. So for evaluation your input reader is your test.record. So now the fifth change will be eval input reader. Inside this you have what? TF record input reader, and inside this you have what? Your input path, and it will also have the same label map path. So this will be your sixth change. By the way, there was also one more change we totally forgot, that is the number of steps, right? This, if you want you can train for 2 lakhs, if you want you can just narrow it down. So this is optional. This one is number 7th one is optional. It is important to remember the changes that you are going to do, alright. So here basically your part to be configured, this will be train.record. Test.record, I'm sorry. And the final one here will be the same path here. So now you have done all the changes, alright. So all the changes in the config file have been done. Now save this. So this has been changed. So now your changes have been done in everything that was required, alright. Now your last part is basically, see, after changing, the next part is basically, here you made the same update changes and all these changes were in the same config file. So we did this whole thing. The next thing will be, we will be copying the train file from the research object detection legacy. So the train file is basically what we will be using for training. Alright, so let us go in here, object detection. So inside legacy you have train.py. Copy this, paste it inside your research. So now what we will be doing is, we will be training the whole thing. So, okay, so you also have to copy deployment and nets folder from research.slim. So let us go in research slim. So where is your slim folder? Here you have the slim folder. From this you will copy your nets and deployment. Copy, and you have to paste it inside research, right? You have to paste it inside research, from research.slim into research. Now you have done everything. Now your next step will be basically training. So this is your whole training, whole code for training. This is your step. So what we are doing is, we are running python train.py, and then we are doing log to st. This is basically means that all the logs will be shown in this terminal here. So this is your training directory. Your training directory is the training. Here you will have the, what is inside training, if you remember, it has the label map.pbtxt. At the same time, this training also has your config file. So that is that. Then you have your pipeline config. Here the only changes that you will be making is this one. So instead of your model.config, it will be this name here. Copy the name. So instead of that, it will be this thing, okay. And now what we are going to do is, we are going to run this thing. Let us see if we get any problems. So now you can see it has started running, okay. It takes some time to load the whole thing and everything, but yeah, it has basically started running is what it is showing here. So now you are getting all these warnings and TensorFlow, you are opening this and that. So by the way, remember, this takes a lot of RAM. So make sure if you are running this in your local, you have at least 8 GB of RAM. Nothing can be done below 8 GB. So please make sure you have that. Otherwise, you are going to have a lot of problems. And when you start the training, right, you will see some things. So this takes some time. Obviously you will be saving the checkpoint in training.model ckpt. If you remember, that was given in your whole thing here, and you have all these files. So now you have started your first step, global step 1. Here your loss is very high, 32.4223, okay, and it takes 22 seconds to complete one step. So right now your loss is super high. So your loss is super high, your loss is basically what, 32. When you are training so that it can be deployed or it can be used by your computer or by your system, or maybe for some other reason for your project or your company, you need to make sure it goes down to 0.08. So this is the least one that you can get, so you need to make sure this goes down till here. By the way, initially it will be that bigger loss. If you see here, see, initially it's 32, then you can see how fast it is going down, right? Now it has come to 15 so easily, and we are in the 11th step only. So for now, because I'm showing the whole thing, I'm just running it for how many steps? For 20 steps, if you remember. But don't worry, I already have one I ran here. Okay, so I already have this one. This one I have run for 1,000 steps. So I have this here, and I will be showing you the outputs based on this. But for now, just to make sure and show you how this is working, we have this. Okay, so this will be running for 20 steps. You need to make sure that you take your time. So initially, if you will see, it was taking a lot of time only for the first step, then it becomes faster. So this is your final step. If you will go inside here, your whole thing has finished, right? So this will be basically, if you go here and inside training, I suppose. So you see here you have some extra files. You just had these 3 files, right? Then you have this CKPT 20 here. This means for your 20, since I ran for just 20 epochs, right? So it stored for my 20th one. So these are the values that you are getting from your 20th value. So here also you have a problem. So now you have your model, but your model is in CKPT format. But if you will see TensorFlow object detection, this only works for what type of model formats? So this only and only works for PB format, .pb. .pb is basically frozen inference graph. So anything that is not .pb will not work. So now our next step is basically to convert .ckpt into .pb. Alright, so that is our next step. So if we go here, so this is basically my whole line of converting it into .pb. So this step is what you are going to use here. So here it has not been given in that, here it ends here only, but you have to convert it. Alright, so that is why I am showing you here this one. So what you are going to do is, this will be running what? Export inference graph.py. So you have to first go and find where this lies. So let us go into object detection. So what you need is basically export inference graph.py. So you are going to copy this and you are going to paste this in research. You have it. Now what you are going to do is, you are basically going to run this command. Okay, let me copy it again. So this is basically your whole step. Here what you are doing is, you are running export inference graph.py. Okay, and this what happens is, it converts your .ckpt into .pb. The input type is image tensor. Since for training these TFOD, right, you always have to put this into tensors, and since this is an image, this is an image tensor. Alright, then the next thing is your pipeline config. This is in training slash, now it is written faster RCN and inception v2 Coco, but we are using SSD, so we are going to make that change here. So what we are going to do is basically, we are going to go inside training and you are going to copy this file name. So we will be making that change here. So your pipeline path is in training slash SSD mobilenet v1 Coco. Then you have train checkpoint. Your checkpoint is basically training slash, inside training you have model CKPT. Yeah, here it is written -1000, but I have trained this just for hyphen 1000, basically for 1000 epochs. But if you remember, I trained this only for 20 epochs, so I am going to make the change here to 20, because I do not have this 1000 file. What I have is model.ckpt20. See, we have model.ckpt20, right? So we have to make that change here, and then your output directory will be an inference graph. So what will happen here is you will get another directory, and that directory name will be inference graph. Inside that, what you will have is the PB, the frozen inference graph file. So now it will be converting that. So the whole thing has been converted. So let us look into if we have gotten any inference graph folder. So there you go, you have the inference graph folder. Inside this, what you are having is this, the frozen inference graph.pb. So what we will do now is, basically your model has been trained on your custom data set. What you will be doing is running this and seeing if it works or not. But before that, since we have trained this for such a small time, right, so I am going to remove this. And I have already trained one for 1000 epochs. So what I am going to do is, I am going to paste that here. So what that means is, the whole thing is same, but that was for 20 epochs, this is for 1000 epochs, so this will work better. So you can finally see how the results look like. Okay, so that is why we are going to make this change here. Now what we will be doing is, we will be opening the Jupyter notebook. So inside this Jupyter notebook, what we will be going through is object detection tutorial. Okay, so we will be running the whole thing, except here we will be making a few changes. So here only we will be seeing all our options. So run this one. Here you have the input. You remember all this, right? We talked about all of this in details in the last class. So the whole thing is same. Here now we will be making changes. So my model name is no longer SSD MobileNet V1 Coco. It has become what? Frozen inference graph. What I can do is, let me just, I have commented all of this out. This is because this was for downloading. So I don't have to download, because I have trained this in my local model itself, local system itself. Alright. So what I'll be doing is, I'll be keeping it like this, and here my model name will be basically training slash. So why I am doing this is, see, this is your path to frozen graph. So my path to frozen graph is basically, oh sorry, it is an inference graph, I'm sorry. So this will change. So path to frozen graph is inside my inference graph. So inside inference graph, you have the frozen inference graph.pb. So that is my path. And now your path to label. So this is no longer in object detection slash data. Where is this? This is inside training. So inside my training folder, I have what? I have label map.pbtxt. So that is where my labels are, right? Now I am no longer going to use this. The reason why is, this is to download the model, but we have trained our model in the local system, so we do not have to download it. So here we will be loading our model. Now we will be loading our label map here. So that is done. This is to load the image. If you remember, I talked about how when loading in matplotlib also, you need to convert it into numpy array. So this is what we will be doing here. Okay. Here we are going to make a few changes. So here you have the test path. Inside these you have test images. How are these images? Image 1, image 2, in that format. But if you remember, we have not added, if you see here inside research, you have object detection, right? Inside here what you have is your test images. These test images are not similar to the images that we have trained on, right? So what we are going to do is, we are going to remove these images, and what we will do is basically use the images that we had. So we will go inside utils, images, let's go into test image, and let us copy some random images. We copied these two images. Let us just keep this. Okay, so let me copy this, and we will be pasting it here inside test images. We will be renaming this as image 1 and image 2 because that is how they were trained here. If you will look here, images were of image 1 and image 2.jpg. So we have to change this so that it is of the same naming convention. Okay. Image 1 and image 2.jpg. Okay, so now we have these images. So what we are going to do is basically, now we will be running this. So we have the load inference graph. Okay, we ran this. Now we will be running this one here. Okay, so it did not show. Again we have to run the matplotlib line. Now let us run this again. Here you have, see, it has labeled some things. So I ran this just, if you remember, just for 1000 epochs, right? So it has labeled this as king, labeled this as king, but you can see the detection scores are not very nice. It is just 69% and 59%. So it can get better. So here it shows ace with an 88%. So you can see here what happened is basically now you got all the values that you needed. You can see these were the size of the images. Let me change this, alright. So that it becomes of a smaller size so we can see it properly. So this is becoming very huge. I don't know what happened to the size. Okay, let me just... Okay, so whatever, you can understand the thing, right? So you can see this is the king here, this is the king, and here you have the ace. So you can see all this, it has been labeled. So this I trained for 1000 epochs. You have to increase the number of epochs to 5000 obviously. So then again it depends on what you want as your data set and everything, right? So depending on your data set you have to train it, and now you can see you have the values. So what we did basically right now is we did our basic object detection, right? We did TFOD, but this we did on our data set. Which data set? A custom data set. This was different. So we did TensorFlow object detection on custom data set. So I know these are a lot of steps. What I would suggest is to practice, because once you keep practicing it becomes easier, you keep remembering, so you don't have to go and read through the blog again and again to understand. So let us start with, again let me just revise very quickly what we did. Okay, so what we did first is we downloaded the models, then we downloaded the models, that is the TensorFlow clone. We cloned the library which was from here, right? The whole library we cloned it here. So this was what we cloned. The next thing we went is into the model zoo, downloaded the models. By the way, if you are ever training, going for a custom training, what I would suggest is you will have the link to utils here. Okay, so what I would suggest is you just keep this, you keep xml.to csv tf records, the whole file format structure, keep it like as it is. In the images, right, inside train and test, just change the images. Just change the images inside train and test and label them using label img. We talked about how label img works and everything. So you have the models that you downloaded from model zoo. The next thing what you will be doing is basically the downloading the data set, downloading and preparing. So in preparing a lot of steps come, right? So what are the steps when you are preparing the data set? So you have label img for labeling, then you have the folder structure, then you have 80-20 distribution. So everything after all of this is done, the next thing you will be doing is basically creating environment, using Python 3.6, activate environment. Once you have done that, the next thing that you will be doing is basically downloading. Downloading. What will you be downloading? Pillow, LXML, Python, and whatever will be required, all the requirements, they are already present in here. You will be provided a link to this also, so they are already present here. So these are the things that you will be downloading. Once you have downloaded those, the next thing what you will be doing is downloading protobuf. So the next thing is protobuf. Here also you have the code to download protobuf, right? This is the code. Okay, so what next will you be doing? Once you have the protobuf downloaded, now you will be converting proto files to Python. You will be doing Python setup.py install. Once all of this has been done, next you will be converting your XML to CSV, then CSV to TF record. You will be making changes in generate TF record before doing this, So generate TF record changes. Then you will be making a label map.pbtxt. Okay, so now a lot of things have been done. You have converted to TF records, you have created your label map.pbtxt. Now you will be using your config file, making changes. From your samples in object detection, you are going to copy it into your research folder in training. And the last thing will be, once you have done all of this, will be training the whole thing, right? So now you will be training. Before training, you have to copy deployments and nets from slim folder into your research folder. And also yes, in your systems also, you will have to, once you have downloaded the model, right, here that you downloaded from the model zoo, you will have to shift it into the research folder. Now all of the steps have been done. Now you will just be running the train file. So the train file is also, where is it present? This is also present inside legacy, and legacy is where? This legacy is inside your object detection. So you will be copying that into the research folder, then you will be running that file, and you will make the changes accordingly in number of steps that you want and everything in the config files. Once you have done all of those, you will be converting your CKPT into PB file, and finally you will be making some changes here, whatever are required. Like here, basically what changes you have to make is your path to frozen file and frozen graph, and basically your path to label map. So whatever little changes you have to make, you will make it here, and finally you will run and you will find how it is working or it is not working. Alright, so this was your very number 3rd project. This is basically to identify the cards, object detection on cards. So now this has also been done. So I hope you enjoyed this video. The next class we will be talking about how to do this thing but using YOLO framework. Alright. Oh no, before that also we will be talking how to run this using Google Colab TFOD, because it is very important. In your system you might not have the CPU, but in Google Colab you have the GPU, so you have to run it there also. That is not going to be that long, don't worry. But yeah, after that, once you have done everything that is done with regards to TensorFlow object detection, then you will be shifting to what is known as the YOLO framework, and we will be understanding how to solve that YOLO framework, how to do that. Alright, I hope you enjoyed the video and keep learning.